Next, we are going to study the composition of vectors by rectangular resolution. Suppose, now let me write the heading, otherwise you won't get it. Composition of vectors by rectangular resolution. Right? This is the heading of our next topic. So, what we do in this topic? Suppose we have three vectors. One, this, second, in this direction, and third vector in this direction. Better, let me take it here in this direction. So, if we want to resolve these vectors, three vectors, suppose these vectors are, let me name them, A vector, B vector, and C vector. These are the three vectors that are there, and you are asked to find out the resultant of these three vectors. You are asked to find out the resultant of these three vectors. So, how would you have found out the resolution of resultant of these three vectors? You have to use polygon law, right? You have to use law of polygon. You have to use law of polygon. But that law of polygon is very tough to apply, right? It's very tough to apply. But there is a smaller and more easier way to find out the resultant of these three vectors, and that the name of that process is composition of vectors by rectangular resolution. What we will do, we will resolve each of the three vectors into its two perpendicular components. For example, we will take this as the x-axis and this as the y-axis. This is the positive x-axis, positive x-axis. This is positive y. This is negative x, and this is positive y. Understood? And negative y. So we will resolve the three vectors. We'll resolve the three vectors A, B, and C into these two directions: positive x, positive y, or negative x or negative y. So let us take A vector, right? Let us take A vector, right? So the component of A vector, if you know this angle, if this angle is known to you, theta, let me take easier name so that I can write. This angle be D. Let this angle be D, right? And let this angle be E, and this let this angle be F. This angle be F. So the three vectors, they are making different angles with the positive or the positive y-axis, right? So you tell me first, if you resolve the vector A into the directions where you will get its components, red components, where you will get one component will be here, red one. The component 1 will be here, and component 2 will be component 2 will be here. Okay, right? So what is the value of this component? Let me name this component as AX, and this component as AY. So what is component along x direction, component along x direction, component along x direction, ax, right? Ax. Similarly, for this b vector, what will be the two components? One will be along the positive x-axis, one will be along the positive x-axis, one will be along the positive x-axis, and one will be along the negative y-axis, right? So if these are x and this is by, right? And the third component C, it is in the negative x direction, right? And this angle f is 90°, right? So what will be its component if this is along x direction and y direction? X direction, it is this only, the component is same as this, but along y direction it will have no component. Along y direction, positive y or negative y, it will have no direction, as the angle between it is 90°. So had there been any component that is sine cos of 90°, if you want to have a component of this perpendicular on y-axis, then it would have been c cos 90°. So it would have been 0, right? C cos 90°, so that would have been 0. So it has C has no component along positive y or negative y direction, because it is in the x direction. So any vector has no component along any direction perpendicular to it. So a vector has no component in a direction perpendicular to its direction. Understood, everybody?
Yes, sir.
So components along x direction, component along x direction are ax, right? Ax was 1 plus bx and c. C is in negative x direction, so it will be minus cx. So it will be minus cx, as it was in negative direction, so it is minus cx. Understood or not? Component along y direction, component along y direction will be ay is in positive direction, so ay minus by, and there won't be any cy because c doesn't have any component along y direction, right? C doesn't have any component along y direction. Did you get my point? So
Yes,
what
sir.
so what is ax? What is the value of ax? Ax is cos a cos of angle d, right? What is ay? What is ay? A sin d. Ay is a sin d. Two rectangular components. A you have divided into two rectangular components with d as the angle, right? So ax is a cos d and ay is a sin d. What is bx? Bx is equal to
B cos E.
b cos
B cos E.
b cos e. What is by? b sin e. b sin e. What is cx? Cx is nothing but c of cos 0°, cos f. What is f? Angle is 0, right? So cx is c, cy is 0. Cx is c, cy is 0. Understood? Cx is C, Cy is 0. So now you have all the values. So now you know, so your diagram, what does it becomes? It looks something like this. It looks something like this. You have a AX component and you have a Y component, right? So now you know this value, you know the value of this, you know the value of this, and you know the value of this, right? So you can easily find out what you can easily find out. You can easily find out the resultant. You can easily find out the resultant. What is the resultant? This is the resultant, right? This is the resultant. This is the resultant, and this resultant, this resultant R, this resultant R will be equal to the root of under root of this. Suppose if this is x and this is y, so it will be under root of x square plus y square, right? And angle phi, this angle phi, this angle phi will be equal to tan inverse, tan inverse y by x, tan inverse y by x.